Okay, guys, just a couple things. You can skip over this part of the course if you like, and then we'll get to this, the word problems in a bit. So if you look at this word problem here, let's just do this word problem, and then after this we'll get into modeling, which is coming up with equations. Okay. So here is a question here about Jason invests $8,000 per year, and this is the relationship that is the value of his investment. Okay, where A is the value in dollars and T is the time in years. So what you end up having is a question, and I said this earlier, where the questions we do all look something like this: y equals a b to the x. So you have a number here, which is our a, which in this case, little a here, which is 8,000. And then you have something that is raised to an exponent. So that's this part here, okay? So you start off with this, and then you're growing with this, and then you end up with this. And in this case, you have uh, A is equal to 8,000 times 1.045 to the T. And we're going to look through this here, and what is the A intercept? Okay, so let's not talk about the A intercept. What is, well, it's not a bad question, but what I'm asking is, what is this? What is this little guy here, and what does it mean? And if you read the question, it's 8,000, and that's the initial amount. Okay, so that, what is 8,000? The 8,000, well, it says right here what it is. It's what he invested. So you start off with 8,000. So if we were to graph this over time, he'd have some money, and it would be 8,000. Okay, so this is what we're talking about, the intercept. And it would grow to a certain amount, and grow and grow and grow. And this is our next unit is all about compound interest and making money. And what you'll see is, because this is an exponential relationship, we know that because the exponent is up top. Okay, it's not x squared like in a quadratic. It's something to the power of x, or the power of t, or the power of a variable. And this guy's going to grow. Okay, so we start at 8,000, and we're going to grow and grow and grow. Okay, so 8,000, and you can write here that's the initial amount. Okay, what's the investment in 5 years, 10 years, 15 years? This is straightforward. All you're going to do is take your calculator, and I'll get my calculator if I can find it, for your phone. I'll use my phone. Find this. And all you do is you take this equation here, and you say A is equal to 8,000, 1.045 to the power of whatever. Okay, so let's do the 10-year question. Okay, simple one here, 10 years. And all you do is throw a 10 in here. So if it was 5 or 15 or whatever, 2, 1, whatever you want, you throw that in there, and you take your calculator and you type in, you get clear first of all, and you go 8,000 times 1.045, then find your exponent button. Mine's an x to the power of y button. Okay, x with a little y up top, hit that guy, and then hit 10, and then hit equals at the end, and you should get a number that looks something like this. Oh, no, it looks nothing like that. Let me go back here. 12, 4, 2, 3.7. And we're going to round to two numbers, because when we talk about money, we either have two numbers here or no numbers here. So if you wanted to round this to the closest dollar, you could. It'd be $12,424. That's fine, I guess. But this is a better, oh, what is just happening? This is a better answer here, okay? If you have this, don't give me this. Don't cut it off to 1 decimal. Don't cut it off to 3 decimals. Don't put the dollar sign at the back. These are things that people are doing these days, because we're using, we're texting a lot more. So people talk about, like 8, you text and you go, oh, $8, and you text 8 and then dollars. Okay, that's used in some place in the world, but we still use this dollar sign first. Okay, you want to put a comma there, you can. It's not ideal. We're not supposed to do that anymore, but it is nice, a nice little break for your eyes, I think. So, and if I'm looking at my calculator right now, on my phone, it actually does have a comma there. So anyway, so that's how you do the word problems. Okay, so that's that one there. If we're going to look at other stuff here, these questions here, we're just figure out, are these linear, are they quadratic, or exponential? And really, let's just think about this. Are they exponential? Are they growing at a certain rate? Okay. So if you talk about something growing at a rate, or even decaying at a rate, so here you have amount of radioactive material becomes half of the previous value. It's getting half as big, and the rate here is half. Okay, so in that case, it would be exponential. If you kick a ball in the air, we talked about this a lot at the start of the year. If you kick something in the air, it comes back down like this, and that guy should look like a quadratic. So it's not exponential, it's quadratic. If you get a raise of $1 per hour each year, this is a constant raise. So this was a tougher question, right? But if you get a constant raise, you get $10, then you get $11, then you get $12, then you get $13. And if you were to look at this and you would chart this, you would notice that the first differences are the same. And first differences are the same, this would be linear, not quadratic, not exponential, sorry. If you get a 5% increase, so the difference here between a dollar raise and a percent increase raise is this one's going to be exponential because you're getting an increase on the increase. So what that is saying is if I had $100 one year, let's say I made $100 an hour, okay, or $100 a day, okay, and I got a 5% raise, I'd get $105 because it go up 5%. But the next year, sorry, if I was to get a 5% raise on this, it'd be a raise on the 105, not the 100. So it would actually be more than $5 because you get 5% on the 100 and you also get 5% on the $5. Okay, so it'd be 110.25, I think it is. Let's see if I'm right on that. Yeah, so 110.25. Anyway, we'll talk more about that later. But notice that this is a percent or a rate increase. So this one here is exponential. Okay, path of a rock thrown from a bridge. I'm not going to ask you guys to do this on a quiz or anything. It's just when something is growing at a rate, this is a rate, this is a rate. You're looking for percentages and that sort of thing, ratios. You'll notice they're exponential. Throwing a rock from a bridge will go up and down like this. Okay, so that's that really. The key to this lesson really, not so much this, okay, but the key to this lesson is can you just plug in to a word problem like this. The next video, the next section of this course is going to be coming up with these equations on our own, which aren't that hard, and then we'll plug in and work on that. Okay, take care.